Hello, welcome to my channel, Devops with Prasanna. This is day 14 in Learn AWS in 30 Day series. And today we are going to deploy the backend tier of the quiz application using AWS Lambda and API Gateway. So this is a demo which we are going to look at. We are going to create 3 Lambda functions. One is to get all the quizzes. The next one is to get all the questions for the quiz. The third one is to compute the score once a quiz is complete. Okay, and all these 3 lambdas are going to be attached to an API gateway. This API gateway will provide the REST layer for this lambda, and this REST APIs can be used in our front-end tier, which is running in the Amplify. And all this lambda and API gateway are going to be monitored using CloudWatch. Yeah, I'm very much excited. Let's get started. In the backend tier technologies, first we'll see the AWS Lambda service. Lambda it's a very popular service in AWS because AWS is the first cloud provider to introduce a concept of serverless. Maybe I think like one of the initial providers to introduce this serverless technology. And it became an instant hit because the pricing model of Lambda is very cheap actually. For example, if you go to AWS Lambda pricing, you can see it is Lambda is charged 0.20 cents per 1 million request. And similarly for the free tier also, there is like so for free tier, like 1 million free requests per month is available for us. So this is like a very generous free tier, and we could able to experiment a lot with Lambda. So that's why like Lambda became an instant hit. And before explaining the concepts, I thought I can showcase a quick demo about the Lambda, which is very cool. So go to Lambda. And instead of this functions, say begin. Okay. This is the first page which you will see when you don't have any sort of any functions created before. I'll use Python. This is a sample function which we already have. They say run. You can see hello from Lambda. For example, if you want to know how Lambda responds to events or how Lambda integrates with other services, then go to next page. This is a cool demo which I mentioned. So for example, we have integration with mobile devices. It can respond to events in mobile devices or some kind of streaming technology, like it could be Kafka, Kinesis Stream, whatever it is. Or it could be responding to events in S3 bucket. So whenever there is a request, Lambda will serve the request, and this is a number of instance Lambda spins up. Let's say like we are sending a lot of events in mobile from mobile. Okay, and we are sending some pictures, storing some pictures in S3 bucket. So the cool demo here is, for example, let's say I'm sending a lot of pictures. You can see the auto scaling is happening dynamically. So Lambda could able to spin up multiple instances and handle the request concurrently. So this is the power of Lambda. Like the auto scaling is there by default, and it happens for anything. Like there could be like a lot of other events which got triggered, and Lambda could able to respond to all those events. And for example, like there is one more cool thing, which is like based on number of invocations, you can understand what is the cost is. We saw like there is 1 million requests per month is free for us. So for example, if we send a lot of information from mobile devices or streaming devices or the S3 bucket, you can see the cost getting increased. After the 1 million requests, the cost will start incurring for us. But yeah, like this is a very cool demo about Lambda. Like I thought, if you want to understand Lambda in a better way, maybe like we can compare it against the EC2 instance, and by that way, like you can understand Lambda. But before that, like just to give a very quick summary of what Lambda is, it is a serverless function, which means you just have to write your own business logic, and all the infrastructure things will be taken care by AWS itself. Yeah, so like we'll talk about the difference between EC2 instance and Lambda. EC2 instance, it runs always. whether you use it or not, whether your application is going to use it or not, if you create the EC2 instance, you need to pay for that. But this is runs only on demand. Whenever there is an event, then only Lambda function will be triggered. And fixed pricing per month. But this is pay per usage model. Meaning whenever you use, you have to pay. If you're not going to use, you are not going to pay. And manual setup for auto scaling and logging. Just now we saw like auto scaling, monitoring, logging, everything comes by default for Lambda. Machine provision is needed. This is because EC2 is coming under the category of infrastructure as a service, whereas Lambda is coming under the category of function as a service. Infrastructure means you'll be given a bare virtual machine with, let's say, some OS in it, Ubuntu or some OS in it. But you have to install all the packages needed for you. For example, if you want Git, you have to install it. If you want Python, you have to install it. But here, there is no runtime provision needed. Runtime provision in the sense you can choose your own runtime. For example, you can say, I want Node.js runtime, and this is a version of Node.js I want. In case of Python, like you can say, I want Python 3.1. That is the version I need. So you can choose a runtime, and you don't need to create any script or something like that to provision the environment. And coding is required to respond to events. So just now we saw like Lambda could able to respond to events from S3 bucket or from the streaming system like Kafka or Kinesis or from the IoT backends. The integrations comes by default with AWS services. But in case of EC2 instance, we have to write code. So we'll know like how to respond to those events. Cool. I thought like this would give a very good understanding of AWS Lambda. Maybe like just we can see 2 examples and then we'll go into the demo part. The first example is, for example, cron jobs. In the past, I have run a cron job to monitor the service. So for each and every 1 hour or every 5 minutes, there is going to be a monitoring system which will poll for a specific API and see if it is available or not. We can do this easily with 2 AWS services. One is Event Bridge, which will send an event for every 1 hour. So every 1 hour, there will be an event triggered. And Lambda has very good integration with Event Bridge, so it can respond to that event. So it can say like it can take the event, it can process the event, and then it can write the result to some database or wherever it is. Similarly, like, this is like a hello world for Lambda. Whenever we talk about Lambda, they'll talk about the thumbnail creation. For example, you can upload an image, and then the Lambda can convert that image into a smaller size image, meaning like a thumbnail. So it can create a thumbnail, it can store it in a different S3 bucket, and it can store some meta information in different database or things like that. So this is possible. And you can see like all these things are event based. So that is the catch here. Cool. I think like this is good. And maybe like we are good to go with creating these 3 Lambda functions. So these are the 3 Lambda functions we are going to create. And the code for this Lambda function will be available in the quiz from Prasanna GitHub repository. So this is the source code for it. Intentionally, I made this a very simple one because I can explain the concepts properly. So for example, this is the first one, which is get all quizzes. So this Lambda function will just return all the quizzes from our data store. And in the next session, we are going to integrate this with DynamoDB. So all the quizzes will be fetched from the DynamoDB database and will be sent back to the UI. Okay, this is the first function. The second function is when we pass a quiz ID, based on the quiz ID, we'll get back the list of questions. So this is going to be the second function. So we'll pass a quiz ID, and based on the quiz ID, we'll get the quiz details, which will have the title and the quiz questions. The third Lambda function is for the computing the result. Again, like this answer will be stored in the DynamoDB table. We'll be using the data stored there to validate the score, to get the score and the percentage of the user. So we'll get the quiz ID and then we'll get the answers given by the user. and we'll have a very small, simple logic to compute the score and percentage. Okay, cool. So we'll create all the three Lambda functions now. So I'm inside the Lambda, and then I'll go into the functions. First, we'll say create function, application from scratch. I'll say demo, get all quizzes. This is going to be a Python 3.5. I'll say create function. In the meantime, I'll copy the code for this also. Cool. So once a function is created, this will be the page for it. I've saved this layers for the next session because it's slightly complicated one in which we'll create a layer for our dependencies and we'll try to reuse it across all three Lambda functions. So that is the objective. Okay. This is a code editor for us. Instead of this, I'll just replace this with our Lambda handler. So it's going to have list of quizzes, and then we're going to return back the quiz. I'll deploy, and then I'll test. So I'm going to create with all quizzes. There is no event to be passed here. It can be empty. Okay. So if I test this, you can see I'm getting a response back as 200, and then body contains a quiz information. Cool. The next one is demo, get questions for a quiz. Then this is going to be a Python 3.1. And this is going to be the source code. Okay. And I'm going to test it. Again, I don't need to pass any parameters here, pass any event here. Okay, let's see test. Okay, so yeah, I'm sorry. So we need to send the quiz ID because this depends on the quiz ID. So what I'm going to do is I'm going to edit the test event. I'm going to say quiz underscore ID. It's going to be 1. Save and then test. Yeah. So I could be able to get the details for the day 11. Okay. And I'll create the third one. Third one is going to be compute score for quiz. Okay, this is going to be a slightly different structure. This is going to be the input event. For the quiz ID 1, this is the answer. Answer is again a hash. It's going to have question ID and then the answer for it. So this is a format. Okay, deploy. Yeah, so I could able to compute the score and percentage for it. Yeah. So now we have created our 3 Lambda functions and tested it using the Lambda editor itself. But without exposing those to the outside world, it is of no use. That's where the API gateway comes into picture. So we are going to add a API layer, REST API layer on top of the Lambda functions. And based on the request, we are going to invoke the corresponding Lambda functions with the proper parameters as well. So what is API gateway? That is an important thing. So Yeah, API Gateway, as the name implies, it is like a gateway service. For example, you can have Lambda or you can have different other AWS services which don't have the REST endpoint. So, or which can't be accessed from the outside world. In those cases, API Gateway is a very good service for it. So we can add a API Gateway on top of that service, and we can allow the external system to talk to that service. For example, we can connect API Gateway, we can invoke it, we can contact API Gateway from the streaming dashboards or web and mobile applications, IoT devices, or like any private applications as well. And API Gateway will have its own caching mechanism, and it has its own monitoring mechanism as well. So caching using API Gateway cache and monitoring using CloudWatch. And as we discussed, like it can sit on top of Lambda or EC2 or DynamoDB or whatever service it is. And even like it can, you can have API Gateway on top of your private applications as well. Cool. So I think like you would have got an idea of like what the API Gateway is. I thought we can discuss about the API Gateway advantages. So you'll know like why we have to use it. So API Gateway, like the first one, it adds a REST API layer. You can add REST API layer or it can add a HTTP layer also. But it always deals with the API. That is a critical point here. It can add authentication and authorization. It has very good integration with Cognito. And then it can pass and modify the request and response. So for example, the Lambda can expect the event in a certain format, but the calling service can send the request in a different format. So here we can create a template and we can modify the input request and pass it to the Lambda in a proper format. So those kind of request response parsing is also like possible. Rate limiting. For example, to avoid the DDoS attack or to prevent the malicious user from bringing down the system, we can set some kind of rate limiting. Rate limiting is, for example, you can say from this particular IP address, for every 1 minute, we should get a maximum of 30 requests. So one IP address, every 30 seconds window should have only like 10 requests. So if there are more number of requests sent from the same IP address within the time period, those requests will not be processed. It will be stopped at the API gateway level itself. And it will send the responses too many requests. So this is to avoid the load in the backend system, like for example, Lambda or EC2 Instance or wherever it is. And then caching. For the request which is already served, we can have a temporary caching mechanism with the validation period in it. So like the results will not be computed again by the Lambda. It will be sent from the API gateway itself. And Lambda and the API gateway is highly scalable. So even if you get a lot of requests, this is a serverless application again. So it knows like how to scale it properly. And versioning of API. For example, you can have two different versions, V1 and V2. And you can route some of the traffic to V1 and some of the traffic to V2. For example, V1 can have Lambda 1, V2 can have the updated version of Lambda, which is Lambda 2. And let's say like 50% of the user can go to V1 version. 50% of the user can go to V2 version. So why you want to do this? Maybe like if I say 50-50, it will not be making much of the sense. But in case, I can say 10% of the users can go to V2, 90% of the user remains in V1. By this way, you have a mechanism to test your new changes for 10% of the users, get their feedback and see how it is. If it looks good, then 100% of the traffic will go to V2 and you can destroy the V1 completely. This kind of testing is possible with API Gateway. Yeah, canary deployments and Swagger. So you can easily generate open API specification using the API Gateway. So these are the advantages in using API Gateway rather than having a plain Lambda function exposed. So yeah, before jumping into the demo for API Gateway, I thought we can talk about certain concepts. So when I'm going to create the API gateway resources, you will understand what it is. So API type. So as we discussed, API gateway can be used for HTTP endpoints, or it can be used for Lambda, or it can be used for other AWS services also. So you can define the type of API gateway API you are going to create. It can be like REST, or it can be HTTP API, or things like that. Resource. So a resource means if you follow the REST convention, you will know like all the objects are created as a resource there. So for each and every resource, you can create multiple methods for it. So for example, you can create a resource called car, and then you can have a get car method, or you can create a car method, or you can update a car method, or you can delete a car method. But all the CRUD operations are acting upon the object called car. So that object is called as resource. Okay. And then the method. So as we discussed, it could be get, put, post, or delete. And then there are like two concepts which we want to discuss, which is the deployment and the stages. So whenever you create a API gateway, you have to deploy that API gateway, APIs. So you'll deploy to something called a stage. Stage is nothing but which we discussed a few minutes before, which is like V1 or V2. So if you create a API, you can say whether it belongs to V1 or V2. In other terms, you can create stages like dev, staging, production. And when you want to deploy, first you can do a deployment to dev environment. You can do the testing there. If it's good, then you can deploy to staging environment, and then you can confirm your changes. And all the UAT testing and everything can happen there. So this is going to be the deployment and stages. This is something which we are going to see in the demo as well. And model. So for like somehow you have to map the incoming request to the Lambda function. So that is incoming request. That is the API gateway, and that is Lambda. So we are going to create models so that we can accept the incoming request and we can pass it to the Lambda events. So for that, we are going to create a model in API gateway. So this is what we are going to do. And this is a concept which you have to understand. So it will be easy for you to follow in the demo as well. Yeah. So you can search for API gateway. And this is a page which you'll get. If you are going to create the API gateway for first time, the page might be slightly different. I'm going to create a API. So if you remember, like we talked about the API type. So it can be HTTP, WebSocket, or REST API. So I'm going to create a REST API. It's going to be a new API, and the name of this is going to be this app. Okay. This API gateway, either you can deploy it in per region, because I'm using a Mumbai region. I can deploy it within this region, or I can deploy it edge optimized. If you remember from the CloudFront session, if it's going to be edge optimized, this API gateway will be deployed in all the edge locations, which means the latency will be like very less if the same application is going to be accessed from US and if it's going to be accessed from India as well. So you can try to based on your need, either you can choose regional or edge optimized. I'm going to choose regional. Okay, so this is the first page which has seen. If you remember, we talked about the resources concept. Resources in the sense the object which you're going to act upon. Maybe like what I want to do is whenever I'm going to hit / endpoint, I'm going to return the list of quizzes. So I'll say I'll create a method at the top level, at the / level itself. The method is going to be get. It's going to be a Lambda function. And then I'm going to choose a Lambda, which is demo get all quizzes. And I'll leave all the other things as it is. We'll see this in the next Lambda function, next API method. Cool. So I'll say create method. This is a very simple one. So when the client requests for something, It will come to this method request, it will come to the integration request, and then it will have the Lambda integration. Basically, if you want to modify some of the parameters, you can do it at the integration request. So you can format your inputs according to your Lambda needs. What I'll do is I'll go to deploy API. I'll select the stage. I'll create a new stage. I'm going to call it as V1, meaning like this is a version 1. Okay, cool. So now I'll come here. This is a method we have. First, let me test it and see how it is. So I'm not going to pass anything. I'm going to say test. Okay, cool. So when I say test, you can see I'm getting the response here. The list of quizzes available. Okay, so now we have our get method at the root level. If I want to test this endpoint from the outside world, I have to go to my stages. If you remember, stages are the versions which we'll be having. So here, if I go here, you can see I have a stage called V1, and this is going to be my invoke URL. So I'll copy this. I'll say V1. If I hit this, I could able to get back the result. So which means we have a REST API layer on top of the Lambda application we have. This is cool. Now what we'll do is we'll create one more resource, which is called quiz. Okay, so now we have /quiz, and then what we'll do is we'll pass the parameters for it. And before that, I'll say create method. Method is going to be post. It's going to use Lambda function. And then I'm going to choose my Lambda function. So I'm going to call demo get questions for quiz. And then in the request body, I'm going to add a model here. So there is no model. So what I'll do is I'll create a model first. So if I go to my API, which is quiz app, you can go to models. You can see there are two models by default, which is empty and error. I'm going to create one more model. I'm going to name it as quiz by ID. The type is going to be application/JSON. Okay, and to define the model schema, like we have to follow the JSON schema format. So, for example, AWS API Gateway JSON schema model. So either I can use this or I can go to this one. So I can use this model here. Maybe I'll copy this one, then I edit this. Okay, so it's going to follow the JSON schema. The title is going to be quiz by ID. It's going to be object, which is fine. I'll say the property is quiz_ID. The type is going to be string. I don't need any other properties. The required parameter is quiz_ID. Okay, so we are defining this model, and this is a model which is going to pass to the Lambda function. So I'll create this one. So we have three models here now. Now if I go back to my quiz app, and if I go here, I can create a method which the type is post. It's going to invoke a Lambda function. The name of this Lambda function is get questions for quiz. And then it's going to have a request body. This request body is going to have type as application/JSON. The model it's going to follow is quiz by ID. Okay, cool. So now I created a post under the /quiz resource. I'll test this one first. So in the method body, I will say something like quiz_ID. I'll pass the value as 1. Okay, cool. Oh, I didn't update the question. Maybe like I'll update in the GitHub repository. But you will get the list of questions and the type and the options for each and every question. Cool. So now we look, this looks good. So we'll deploy the API now. We'll select the stage as V1 itself. Add questions. Okay, so cool. So this got deployed, which means we could be able to use this URL again. What I'll do is I'll go to Postman. I'll create a new request. I'll say the method is post in the body. I'll give JSON this underscore ID. Okay, if I send this, missing authentication token because I didn't pass the resource properly. So if you remember, slash has the only the get endpoint. It doesn't have any kind of post method, but quiz resource has the post method. Cool. So now we got the response back from the Lambda function. This is great. Okay. So now we are going to create our third method, which is to compute the score based on the answers. So what I'll do is I'll create one more resource. I'll say the name is compute score. Create resource. And then I'm going to create a method here. The type of the method is going to be post. It's going to invoke the Lambda function. And then I'll choose a Lambda here. Compute score for quiz. But this time I'll not give any request body because I don't want to do any kind of validation. I just want to pass whatever I have from the client. I'll directly pass it to the Lambda function and get back the result. Okay. So I'll say create method. Cool. Now we have this compute score. What I'll do is I'll go to test in the request body. I'll say quiz ID and the answers for each and every question. If I invoke this, yeah, I could able to get back the response, which means this looks good. So I can go and deploy my API. I'm going to deploy it in the same V1 stage. Add compute score functionality. Cool. So this means again we got the invoke URL. So I can go to my Postman client. I'll say post / compute result. The body is going to be quiz ID answers and this one. If I invoke this, I will use a compute score. It's a compute result. Okay, cool. So we could be able to see the score is 2 because 2 questions are correct, and then the percentage is 67. I think this is 3. Yeah, so it's 100%. So this is cool. So I think like we reached the end of the demo. You can see like we created 3 Lambda functions. We added a API layer on top of it. This can be integrated in the Amplify frontend. But just before ending the session, I just want to show the monitoring aspect also. So for example, if I go into my functions, for example, compute score. If I want to see like what's happening within this Lambda function, I can go to this monitor and then I can go to CloudWatch. So the first thing is like, you can see the metrics here. There is an invocation count. So it got invoked one time. And what is the duration of this, the invocation? So the Lambda function ran for 2 milliseconds. And then if I go to CloudWatch, I can check the logs as well. So compute score for quiz. I can start training the logs. So it'll just wait for the logs. Now what I can do is I can go here again. Maybe I'll try to send something different here. 4, then 1. Okay. So I can see my score is 1 and this percentage is 33. And then we can see the messages for it here, like submitted quiz for 1, and then the response output. And similarly, you can see like the report of this one, like what is the duration of this Lambda function, and then the build duration is 2 milliseconds. Like it will be rounded off to the nearest millisecond. Cool. I think like this looks great. This is what we want to do as well. Maybe in the next session, like we'll try to integrate this with DynamoDB, so we can have a database integration and fetch all the information from the database. Cool. I hope like you learned Lambda and AWS API Gateway. Happy learning. Bye bye.